You guys ready to do some debugging? Guys and gals, ready to do some debugging? Yeah. All right, well, we'll do our best. Tan did this presentation. I didn't really change much, so I just left his name on it. Everything I know is from Jenny Bryan. Apparently it's a package. Jenny Bryan has done most of the debugging talks and wrote a book, Jim Hester, with a lot of things about R. These are some good resources. Definitely the object type closure is not subsettable is a great introduction to debugging. If you're not too familiar with it, that's a great way to become familiar with the different methods for basic level debugging. And I haven't read that book, but chapter 11 is on debugging. And then this is a video of Hadley Wickham demonstrating how to make a reprex for a Shiny app, which is kind of, it's a good thing to know because Shiny apps are pretty notorious for stumping people as to how to submit issues, because the issues are often submitted as like, hey, my Shiny thing is doing this. And it's like, great. That can mean a lot of things. So yeah, definitely learning how to do a reprex is really key to getting good help. If you're not familiar with what a reprex is, definitely check out the tidy first page on creating a minimal reprex, or watch this video. Oftentimes, if you're thinking about going and writing an issue on GitHub or like asking on Stack Overflow, just the simple like creating a reprex will help you to solve it. Like you'll just solve it in the process of creating the reprex. It just is a really helpful procedure. It is also kind of time consuming. So ideally you exhaust all other methods of debugging before doing a reprex, because it's fairly time consuming. Okay, so all the ways in which debugging has happened can happen. I'm going to go through these, but I'm going to go through them all at once, and folks just like raise your hand if you have done or tried these types of debugging, so I can get a sense of like what kinds of debugging people are familiar with or have exhausted before, and what kinds of debugging would be good to look at. So print message debugging. Yep. I feel like that's everybody. I feel like is that where most people started? Did y'all like, that's where I started. Yeah.
The classic like here, I should put like a message like here, all capitals, or here one, here two.
Right? Yeah, exactly that. Like totally non-descriptive, just like I'm gonna print out whatever piece of data is coming through, or like where it is in the execution, just so you know how far you got, right? And then you just move it down a line each time. Yeah, so
club, that was the only debugging type I'd ever been like taught by somebody.
Yeah, totally. Same here. I feel like that's where like everybody starts. Okay, so we won't go much into that one because it has limited usefulness and it sounds like everybody's got experience with it. Has anybody used the error or last error, R-lang last error, to recall an error? I see some nods, yeah.
It's kind of automatic in a lot of the tidyverse stuff now, isn't it? Where if you get an error and then you can press one of the response buttons or the warnings thing, and then it will just bring it up automatically.
Yep. Yeah, that's a really nice feature of just about everything in the tidyverse. Is it now prints out verbose errors? Often it prints out the trace too, or at least some of the trace.
Yeah, that's really cool.
And so yeah, between error, like you can type error or warnings, or traceback, and those are going to give you R, base R related errors or tracebacks or warnings respectively. And then in the tidyverse, it's going to give it to you automatically, but often last trace will be abbreviated and you'll just get a ... And if you want to see like the full trace stack, you can call rlang last trace and you will get something that looks like this. So you'll see the like AST familiar, the stuff we were doing with lobster earlier. Let me make this bigger. I see people like getting super close to their screens. So you'll see that thing that looks familiar to what we saw with lobster, where you got, in this case, a magritter pipe, and then it's dropping down into the functions and showing you what function the error emanated up from. So fairly useful. And then it'll also give you just the error itself and tell you what the error is. And we're going to take a look at that one in a minute. So that one is pretty straightforward. Browser. This is a one that I think is less familiar to folks. Anybody use browser?
Like twice.
Rudo? Twice? Yeah.
I've used it once after following. I have watched Tan's talk before because I mistakenly looked at it when I was researching another video, but I don't know how to use it properly.
Haven't used it? Okay, cool. Then let's deviate and let's take a look at how browser can be used. So it works if you wrote the code, is the best way to do it. You can also use, I think June said this, trace. If you want to like edit code that has already been created and you want to add a browser, I think you can use the trace. I've never actually done that, but browser is really good if you want to debug your own code. So say for example, I'll try to do one that is probably more familiar to people instead of just like going to one of the packages that I've been working on. Let's see, which R session. This R session. Okay, so say for example, we want to do something interesting with mutate. Let's take a look at this data set so we can see what this looks like. I'll just view it. Browser definitely comes in handy with this. So this is probably going to look familiar to anybody who's worked with time series and financial data. It's just minute by minute bars of the stock data for Beyond Meat since Valentine's Day to now. So all numeric except for time. And this is actually in a Sybil format. So it has like an interval feature like attribute, and it is ordered by default. It's basically a TS, like the time series data class, but it's a data frame. It's actually a Tibble. It's built on Tibble, so it's a lot more useful than the TS class. So if we look at this and we want to do something, say we want to, what do we want to do? We want to do some kind of complex function that does something with open, high, and low. Say we want to calculate a range between high and low for each minute. And so we're going to go to mutate that and say our range, we're just going to pretend that it errors for a minute. So we're going to do an anonymous function. I think you can do anonymous functions like this in mutate. And we're going to say range of, we're like low, high. I don't know if this is actually going to work. We'll see. So if we don't know it's going to work, this is where we can use browser. So we can actually create browser inside of the mutate call. Range must be a vector, not a formula object. Okay, so what is it? That's right. It has to be like this. I'm pretty sure it has to be something like this. To get it to work with. Mutate. Let's see if that works. It used to work.
Talking about this. I think you can just.
Oh yeah, wait. Parentheses. I think this will work. Yes, there it goes. Okay, so yeah, if you want to do an anonymous function inside mutate, you can do it like this. I think you might also be able to do, so you wrap function in your function in parentheses, and then you pass the arguments with the next parentheses. Or I think another way to do it might be to use rlangs as functionality. But I know it's going to do something different. No, that doesn't actually work. Okay, we'll stick with this. Okay, so when we do this, it pops open in browser. And so browser will open a window that shows the interior of the function that you stuck the browser call inside of. And so when you do that, say like in mutate, we can now look at what's in the environment. And we can see what gets passed in. So we have like high, low, we could also do ls to see it. And what's interesting about these is if we turn on all names, we can see that there's actually hidden arguments. Well, maybe not in this case, but in per, there's always hidden arguments. So we're going to look at what high and low are. So it's passing in high and low as the entire vector. Let's see if it's actually a vector or if it's actually a like data frame column. So it's a vector, it's a numeric vector. And so if we made this row wise, it would be different. Let's actually do that. Looking at what gets passed into mutate calls row wise. Right. Oop. Okay. So now if we look at what gets passed in, high is just a single number and low is just a single number instead of the entire vector. And so basically if it passes in the entire vector, then we're going to need to use either a map function or some kind of vectorized function to be able to act on the entire vector. But if we do row-wise, we can act on each individual combination of numbers in the row. So if we actually do range low high, then, well, it has to be like this, I think. Yeah, it's got to be. So you can't actually edit this, unfortunately. You'd have to edit in the console. You can go to the console and do it. Why am I not getting range to work?
It's working. That's how it works. It just prints it, the minimum and the maximum.
Oh, that's right. That's right. If there were more numbers, it would be just that. So we actually, what I was hoping for was diff. There we go. Okay. But let's see, it went from, yeah, 179. What's low? Okay, yeah. All right, so we're gonna get the diff of that. So we can stop I'm going to add something else in here so we can see how to progress through. So if we're going to take we'll just make it multiple steps. So we'll say range, and then we want to take the diff of that. Yeah. So let's call this again. Oops. Okay. So when we're browsing, when we're in this browse mode, we can step through the function by typing in, and that's going to go next. So it goes to the next. And if, say, we wanted to go look at the interior of whatever function we are on, we can do S, and that's step into, or you can do this little button here, which will step into the function call, or you can do the keyboard shortcut, which is Shift F4. So if we do this, it's going to step into this function. And so now we can see like all the what's getting passed into this function. And we can also see that there are hidden features there. So there's a ... So if we go rlang dots list, we can take a look at what that is that's getting passed. Oops. So it's dropping us way down into this call stack. And it's going to bring us back up to the top level. Okay. So dots list doesn't work. I think list 2 will work. No, that's interesting. Well, I guess the way ... works with range is different than the way it works in the tidyverse. This works though. Yeah. I have never seen recursive as an argument to C. Has anybody ever used that before? Yeah, so you learn a lot of things by stepping down into functions. I never knew C had a recursive argument. I guess that's maybe, is that still documented even? Yeah. If recursive, the function recursively descends through lists, combining all their elements into a vector. Oh, that's interesting. It's almost like unlist or flatten. Cool. So when you use S, something to be aware of is it continues to step into functions deeper and deeper. You typically don't want to go as deep as the tree goes. So you have to use in again to start stepping stepwise through whatever function it is. And so then when the function returns, it pulls you back up to the top level. And so here we are at the top level again. And you can also hit enter if you're in next mode, or if you're in step mode, you can hit enter to progress down. But yeah, enter has multiple uses, so it's not typically advisable. There are also buttons for each of these. Next is equivalent to N, or you can hit the F10 button, and then F, which is finish, or you can hit this button. That will go to the end of whatever function you step down into. It'll just finish the execution. Or if you're in a loop, it'll finish an execution of a loop, and it'll start back at the beginning if you use F. Q, like capital Q, will break out of browser. Just Q and enter, and that will pull you back out of browser. You can also use escape to come out. I'm pretty sure escape brings you up one level though. So that is a neat way of like getting down into a function. So if we remove row-wise, like often what I found myself doing is something like this, where what goes into the mutate, I want to like map along something. And so I'll go inside of here and use like a map function and map along it with a anonymous function to do whatever it is that I want to do inside of the mutate. So another thing mutate can do, or not mutate, browser can do, is you can have it do only call browser when certain conditions are met. So we want to say like, we'll say if this expert argument, if we assign this, if out is greater than 9, we'll say if there's a range greater than 9, like a really quick fall in the value over the course of a minute, then we're going to call browser. So that's like if you suspect that certain data is causing an issue, you can use that. So here we go. So out is 57. So it dropped more than 57 points in the course of one minute at some point in time, which is a massive, massive drop. It's like millions of dollars being withdrawn all at once. And we can see like, oops. That's because we put the vectors in. One sec. Let's do this again. Okay. So let's make that threshold a little bit lower because it did not do it. Okay, so this made it. So we can see what the high and the low are. It's not too informative. So what we could also do is pass in time, and we could see where in the data set it actually happens. So now we can see that on the 26th of February at 9:31 a.m. is when this drop, it's when there was a massive change in the value. And I remember that day is the day after they had their quarterly report, and it was bad, and people took a lot of money out. So that's what that is. So that's how browser works. It's useful for getting into a function, especially like a Lambda function that you write to do some custom thing with a data set. And you can get inside and work with the interior environment there to do whatever you're trying to do, instead of just having like, you're just plugging a function in here and it's not working for some reason and you can't figure out why. Browser's a great way to get down in there. Okay, let me back up. And so we can use this later. Okay. Take that out. So that's browser. Okay. Browser's pretty useful. Debug, debug once, and undebug allows you to step through a function that you know is problematic. Has anybody used debug or debug once or undebug? No? No? Okay. So debug, I have an example over here that we can use. This is also, see a little bit about unit testing. So if you encounter if you're creating a package and you encounter an error, it's a good idea to write a unit test that will identify that error so you don't mess that piece of code up again in the future. And a unit test looks like something simple. So say in this case, we're looking at a function called get headers. So there it is. Okay. So in this case, there was a failure here in our test suite. And it says it's on line 19 at column 3. So line 19 is this unit test right here. And it's saying that the names of the comparison that we were doing, we were expecting these values to be identical. And it's saying that it expected it to be these names, but the actual names are this. So what we need to do there is we need to debug this get headers and look at what's going on in there. So there are 2 ways to do that. Debug once is a one-off. So when we run get headers, it's going to open up get headers so we can debug it just one time. And then in subsequent calls, it's going to no longer debug it. So we're just going to use debug once. Oops, we need to load this. Okay. So if we debug that and we run this piece of code, I think it's going to let us do it. Yep, so here we go. It opens up in debugging mode, which is just at the very top of the function. And so we can use next, and we can start stepping through the function, and we can get to the end, and it's going to give us an output because that output is actually coming, that failure is actually coming from inside here. And so I happen to know that that is right. And what we're actually need to do is update this. So that's how debug once works. And the only difference is that if you happen to have multiple calls, so I can show you an example of why you might not want to use debug mode and where debug once is more appropriate is if you've got you're debugging a sub function that's going to be called multiple times from a top level call. So where is the Elliott wave thing? Okay, so if I go like debug here, and I'm going to say I'm going to debug response text clean, which is just a function that I know is inside of a package. And if we call this, it's going to start debugging every single time, even when we don't have an error. And you might get called into the debugger a bunch of times, even when you don't really need to be called into the debugger. And so then it's going to keep running. If that does happen, you can always use F to go and finish the function and get to the next call. But in this case, this is going to actually error here. And it's going to error right here. So if you already know what an error is, you can use debug to go to the line that you know is problematic and stop. Don't continue the debugger, because if you take the debugger and run the line of code that errors, it's going to kick you out of the debugger and back to the top level. So you can actually run that line of code from the console. I guess that was not the problematic run. One of these, or I guess it's just calling it again. I changed it. That's right, I changed it back. So it's just debugging over and over and over again. And that's where you might want to use debug once, just do it once. So this is actually going to error. And it's going to error on the second time through. Okay. So I want to get to the error here so we can see how to use the next thing, which is utils recover. I think it might give us an option. It might not. Okay, so it doesn't give us an option for utils recover. But so the problematic line there is out is actually null. And it's trying to set an attribute on that. And so we could go into this function, we can figure out what's going on there and fix it using debug mode. Let me think. How can I get utils recover to get pulled up and make sure options is set up properly? Yeah, so this next thing, options, errors, utils, recover, changes the way you encounter errors. So y'all are probably used to just seeing an error show up in the console, just the red text and maybe a traceback if it's a tidyverse function. But you can also have an error pull up the utils recover. Is anybody familiar with utils recover? Anybody used that before? No? Okay, so utils recover is useful because it allows you to bounce around the call stack and figure out where your error actually occurred. So let me make sure that it's the option is actually enabled. So for some reason, it's not set in this section, so I'm just going to set it. Okay, so now I do believe we're going to go ahead and undebug, or no, we're going to use debug. We'll just go ahead and call it. All right. So we're going to use F to get through this first call because I know it functions fine. And this is the problematic call. So if we get down here to where it errors, and we run this line of code, I'm just going to run it at the console just so we don't get kicked out of the browser. It's going to pop up the recovery dialog. So this is really useful. I actually set this globally for R, so it always uses this. Basically, whenever an error occurs, it opens up utils recover, which allows you to see the call stack, just like a traceback, and it allows you to choose what function you want to go into the environment of to debug your code. And you can go anywhere in the call stack. You can't progress like you can in browse, but you can at least go in. Say we want to go to like the top level of this function, you can at least go into it and you can see every variable in the environment and you can do whatever kind of work you want to do at the console. But you can't step through the function unless you call a function and debug it or call a function with browser inside of it. But it allows you to like examine all the variables and what variable might have caused the issue. And if you want to get back to the recovery and go to another section, you can go utils recover and just call it at the console and it'll pull it back up and you can go like down into the call stack somewhere else. And so if we go down to the call stack here, like I can see, oh, you know, the error is coming from the API and it's saying this is an invalid time frame. And I know that's not the case. So I went and posted an issue with the people that run the API. So that's how utils recover works. It allows you to hop around in the calls, like inside of a traceback, basically, and look at your data, look at what variables are getting passed in, and debug what caused that error specifically. It's super useful. And to get out of it, you can either escape out of it. You just keep hitting escape. So escape is going to bring you up through the call stack. And if you keep hitting it, you'll get to the top. Otherwise, you can just do Q and enter, and it'll pop you out of it as well, all the way up to the top. So that is utils recover. This is useful in certain cases where you're trying to debug a warning. Sometimes a warning will crop up, and say if you're writing a package, you don't necessarily want your user getting a bunch of warnings from a sub package, because you know for a fact that like whatever you're doing doesn't need to be generating a warning for your users. So you can either use suppress warnings, or if you want to figure out like, well, actually, is this something that I need to be aware of, and could this cause a problem for a user? And you can go options warn to, and that is going to throw an error for every warning. And in combination, if you set options error utils recover, it will also pull up the call stack, so you can look at the data that actually threw the warning, and determine if that warning is something you need to heed, or if it's something you just need to suppress. So that's options warn to, and to bring it back to normal, it's options warn equals 0. We'll make it just warnings will throw normally. Okay, and here's the, does anybody run in parallel? August, do you run in parallel? Yeah.
I do use mice in parallel, so that's imputation.
Yeah, mice. That's an awesome package.
Oh,
How
and
many people?
And clustering too.
Oh yeah. Okay, cool. How many folks have debugged parallel code?
No.
It's a beast, especially when you run it in sequential and the error does not happen. That's when you've got a real problem. So, and that sometimes happens. So there's a useful package. Well, to qualify this, catch-r isn't necessarily needed in all cases nowadays. The fur package, if you ever use fur, which is like parallel per basically, has a lot better like message surfacing capabilities, like returning errors and whatnot. I don't know if anybody here has used like Snow or Parallel, or what is it? Starts with an F. It's like the older Parallel packages, but debugging in there,
For
like
each?
For each is what I usually use.
for each,
Yeah.
yeah. So that's a beast to debug because it doesn't even surface messages out of your parallel processing. So there is a way to debug it though. And what you can do is, I think with for each, there's an std out and std error thing. Let me see, I'm pretty sure there is.
Yeah, I think it's like an extra argument to save stuff like that.
Well, it depends of the backend you use, because do Snow allows it, but I was trying to work on a package, but then the CRAN doesn't allow to use do Snow anymore because it's been superseded or something.
Yeah.
So I moved to do future, but then I've been trying to do this actually, like to save the std out messages into log files, but I have not been able to save messages generated with message, the command message.
Exactly.
Only the prints, and I give up at some point because I had some other stuff to do. So this is gonna be handy.
Yeah, so that's I ran into the exact same issue with the older parallel packages. I would say honestly, I'm gonna go through how to do this, but most parallel stuff can be done with fur, and it's a lot easier than the older stuff. So like in this project that I was working on, I used to use some really gnarly for each stuff. Let me see. It's in, there's like a deprecated folder that I put in here somewhere. Oh, that's right. It doesn't show. It doesn't, no, should show it. Where's my deprecated? It's in here. Okay. I think they still have it. Let's see. I think this is one that has the really bad stuff in it. Yes, this is one that has it. Oh my God. Yeah. Yeah, so this is some old for each code that has it. So what you can do with for each is when you make your cluster here, so Windows uses PSOC clusters. When you make your cluster, you can pass out file, and you just specify a file that you want your std error and std out to go to. And what that's going to allow you to do is make it such that you can print messages, like here. You can print messages to those files, to that file. And then I wonder, I was hoping to set up something so I could actually demo this, but I didn't get the thing working that I was hoping to get to work. But so basically that's how you do it, this out file argument. So when you make your cluster, you send it to your out file, and then what you can do is there's a program called Snaketail. I think there's Snaketail for Mac. You can just look up like log tailing is what it's called, like log tailing. And what that does is, I wish I could demo it. It basically, you open up Snaketail or your log tailing thing, and you can tell it to open a file, and you open your std error log, your out file, whatever log it is. And when you do that, it will open it in real time, and it'll automatically update every time a new line is printed there. So like every message, it'll be like the console, basically. You can see every message come up in your file. And if you get a good tailing program, you can also do things like set, like this has a feature, where is it? I guess you have to open a file to have it, but you can set custom like regex, regular expressions, based on certain types of things in your error messages or just your messages that will be highlighted, so you can see like your progress. Like you can have it highlight certain types of messages that are like there's a missing value, or this particular computation didn't actually work. And you can see that, and still you can like put on pass with for each. You can say error pass if you don't want to like kill your whole parallel computation when an error happens and lose all of the like hours that you've been running it. You can say pass, and then you can just use message. And if the error comes up, you can use regex to like highlight anything that says error, and you can just see what errored and still get to the end of your parallel computation and save the data that it did work for, and then go back and figure out like what in your log, what actually errored, what piece of data errored, and fix that without losing all of that parallel work, computational clock cycles. Yeah, so that's basically the way to debug parallel code running with for each. There's also, when you're running with fur and you're doing like anonymous functions with fur, so I converted all of this package to use the fur package and catch R. I'm still using an out file, but if you're working with fur, where is it? I know there's a fur call in here somewhere, I think. No, not in that one. Maybe this one. Yes, here's fur. So like this one, I'm using a future IMAP, which basically just distributes different pieces of this list to individual workers automatically. There's a function called catch_r, and what catch_r allows, or a package called catch_r, and what catch_r allows you to do is, so this function here automatically, we'll take a look at it because it automatically uses it. So this is just a little custom thing that I use to create a cluster with an out file, and also create this thing called a catch function. So catch_r has this catch function, and it allows you to say you want to like both write to file, muffle messages and warnings, and you want to catch all of these and surface them with whatever condition class you want to make a message, and you want to write that message to a file, and you also want that to surface to the console. And so when you use catch_r, it'll both make a out file, and it'll surface stuff to the console. So you can see either one, like you can see the console in real time to see if errors are happening, and you've still got your out file where the errors are also being deposited. Yeah, I think, I honestly haven't checked on fur. There's been a lot of updates to it. The functionality that catch_r provides might have actually been integrated into the package, because I know the author of catch_r was talking to Davis Vaughn and the team that was doing future to integrate its functionality into the actual future package, so you don't have to use another package. Okay, so that's parallel debugging. Anybody have any questions about doing that?
I just have a question about the fur. Does it have the the reproducible random number generator, like the do RNG with for each?
That's a good question.
I think it does, because I was doing something with pseudo random numbers and it got me a warning that you have to set an option.
Yeah.
Let me find it.
I think it's for options. Yeah, it's in like for options.
Because I only really use this for like
Yeah,
Random.
seed.
doing something 100 times. Okay.
Are you talking about the random seed, like the where it starts at, so you can have a reproducible randomization?
Yeah, so like usually I use the do RNG with for each, and so it's just will like make it reproducible.
Okay. Yeah, I think it's the equivalent argument is seed.
It's like its own package. It's do and then capital RNG. All
Okay.
one. But I think it's its own package.
Oh, okay. Yeah, I think if you use the seed argument, you can create reproducible randomizations. You just set the seed at a given value, and it will, when you run it again, it'll reproduce that random number generation. Yeah, and it's for options. It's not an argument to the actual for functions themselves. It's like an options argument that goes into for. So it also now has progress built in, so it'll print like a little like building bar across. It works, it sometimes works fairly well, and other times it doesn't work very well. but in most cases, you'll see a progress bar showing you how far you are in your computation, which is kind of nice.
Using the progressor package. I love that one.
Yeah, that's actually what this progress is built on. They put progress R into for future for a package.
Yeah. I used to find it like cumbersome because what they say is it's an API. So you enable your functions to have like the progress, but then you don't explicitly show it. Users should do that by themselves. Oh, I mean, that's the whole logic of this. Like, I mean, you enable them. It's up to the user how they want to show that, because then you can do different handlers. Well, what I usually do in my packages is that I have another function called like PB, progress bar, and then I say, okay, you just have to pipe the main function call to this progress bar, so it will display the actual progress bar. Because then they just want to see a progress bar. They don't care how you handle it. That.
Does that work if you pipe it?
Yeah.
Because what? Oh, really? Because I thought that like each segment in the pipe happens sequentially. So like the function before it would have to execute before it got to the progress bar one.
Yeah, let me share an example.
Okay.
Yeah,
I will.
this is probably not good practice, but I would just put in the chat. But it works.
Oh, okay.
So this is something I do for work. There's the link. And then you probably can see the code. But yeah, I just tell them pipe the main function call to that function PB that I call. You have to go down.
Oh, to display progress bar. 1 sec, I'll just search it. Okay.
There. So you see, I just tell them do this, and then I tell them if you don't do it, and not have to use the pipe, or you don't want it to use, then you just can put this in argument. Like
that's interesting. I thought that unless you were using like the future version of the McGritter pipe, that it like stops on each segment of the pipe before it executes the next thing in the pipe. Like it doesn't just run all the way through the pipe and then execute them. Like that's what a future would do. It goes like 1 and then 2 and then 3 and then 4 and waits for each to finish.
I don't know, it works though.
Cool. Okie dokie. That's good to know. Yeah, progress bar. I think it's more so built for people building packages or functions to be able to add that functionality to their functions. Where's their thing? Okay, so that's all the things. Oh yeah. What time is it? It's 5:59. I can show Shiny debugging if people are interested, but otherwise it's time. Does somebody raise their hand about Shiny debugging, or am I like no? Okay, so I will say that Shiny debugging. Yeah, what's that?
Maybe in the future.
Okay, Shiny debugging. Yeah.
So I was just going to say, it's like next week's micro benching, right?
Yeah.
That's quite a short chapter. We could potentially add that in there. I do think it's a really good thing to learn about the Shiny debugging, because it's. I mean, I don't use Shiny a lot, but I do expect you probably use it more in the future. I think we all do because of how useful a tool it is. But personally, we just swapped over to daylight savings over here, and I'm shattered. Taking it from a selfish perspective, sorry.
Yeah, no worries. The good thing about Shiny is browser now works in Shiny. Like, so if you stick a browser function in your Shiny package, it will open up inside of that function properly, which wasn't the case like a little over a year ago or so. But it is now the case, which is very useful. You can also like create a custom button that you hide in your Shiny app that you can just like turn it on by changing something in your browser, and then you can see the button and then you can click it, open a browser, and you can use utils recover to go anywhere in the execution of your Shiny app. It's semi-useful. Yeah. Well, now that y'all are professional debuggers, assume you will not have any issues in our code ever again.
It's very unlikely.
Yeah, it's a super useful skill though. It's definitely really makes things a lot easier.
That was really awesome. Thanks, Stephen. It's incredible to see someone else go through a debugging process.
Yeah, thanks. My pleasure. I've been doing so much of it lately. It's just like, ugh. Just sitting in that browser thing, like popping around, like debugging stuff. It's kind of fun, but it's also just like needles and haystacks, you know?
Mm. It's always like that, though. I'm more of the print and find out where you click, where it is kind of thing. Although more recently I started using traceback a bit more.
Yeah,
I think that's becoming more common because of how it's been implemented in the tidyverse, which is really cool.
yeah. Your next level up is utils recover.
Mm.
Just go straight to the point in your traceback that you want to go to.
Mm.
Yeah, I think I might have to start using that a bit more. But the browser bit, that was really cool.
Yeah.
Yeah,
That's,
yeah, that's pretty useful.
I've been like manually doing that kind of, where just like save every argument and then walk through each line of the function.
That's what I do too.
That's the way I did before I was like, oh, browser or debug, because that does the exact same thing that you want that you do with that.
It's like you don't have to worry about saving over things and
Exactly, overwriting things in the global environment, and then you like run it and you think it works, and then you clear your global environment and you realize, oh wait, it doesn't actually work. Yeah. That's what debug and browser are for sure.
Yeah.
There's also like,
really
I did not mention, there's also a breakpoint thing that I think Merck swore if you're just like building analysis code, like breakpoints will work better. You just like click at the left of the screen, like right over here, and you can like set a breakpoint. And that basically works like putting browser at that line. It will, if it's hollow, but if it's a hollow circle, it won't work though. But if it's not a hollow circle, it will work. And sometimes you have to like reload the package for it to work. There are certain instances where it won't work, but it's also a useful feature and you can like take those out pretty easily.
That's the one that I actually use, but then it's annoying because then I use it to build packages. So when I put it and I change the line of code, it will say, oh, you have to rebuild your package. Otherwise, I won't recognize that new line there.
Exactly. That's the really like semi-usefulness of it. It's not super useful because of that.
Yeah.
Yeah.
And sometimes I have like a lot of stuff. Sorry.
Yeah. With browser, it'll stick there until you take it out. Yeah, also when you reload the package, debug gets wiped too. So if you were debugging something, it will no longer be debugged and you'd have to call debug again once you reloaded the package. It is also, you can use debug to debug other people's functions. So if you encounter an error in a package, or you can use utils recover. If you set the error equals utils recover, you can go right down into their package, like where the error got thrown, and you can figure out what went wrong and like make a pull request or open up an issue with a lot more detail as to like exactly what data you put in and exactly where it occurred and like what you think is likely, because often you'll be able to interpret like what's going on in their code and have a good intuition about it. And they might even ask you to do a PR for it, and you automatically become a collaborator.
The dream.
Yeah, right.